Sulfur and sulfuric acid. Sulfuric acid has spent a lot of time as king of chemicals. इंडस्ट्री में ये बहुत इंपॉर्टेंट होता है, ठीक है, और हम इसे यूज कर रहे होते हैं बेसिकली सल्फ्यूरिक एसिड को मैन्युफैक्चरिंग के लिए. हमारे पास ऐसे एक तो पेजेस आगे जाके हम एक काफी अच्छी मैपिंग डायग्राम शो करेंगे और उसके सारे यूजेस डिस्कस करेगा. And to start with, only this is the book among all your books or reference books which goes with the mining process, which is frost process. ठीक है, माइनिंग इतनी इम्पोर्टेंट नहीं है. अगर आप पास 10 years पेपर्स पिक करें तो माइनिंग हार्डली कोई से 2 साल ऐसे हैं जिसमें डिस्कस हुई है, वो बहुत थोड़ी. ठीक है, माइनिंग बहुत इजी है. सल्फर ओवरग्राउंड तो बचा ही नहीं, जितना है वो सारे का सारा अंडरग्राउंड है, और अंडरग्राउंड सल्फर बेड्स की फॉर्म में होता है. सल्फर इज अ येलो नॉन मेटल, so what we do is that we send in hot water melts the sulfur in sulfur beds, then we send in some compressed air, and compressed air actually forces the molten sulfur up to the surface, and then we have pipes to get that molten sulfur out along with the air. So this is frost process, how we get it. Basically, sulfur is used to be converted into sulfur dioxide, and that sulfur dioxide is further converted with the help of contact process into sulfur trioxide. Sulfur trioxide in this process continues to form oleum, which is then converted into sulfuric acid. काफी सारी डिस्कशन यहाँ पर भी है, लेकिन उसे मैं स्किप कर रहा हूँ क्योंकि वो आगे भी काफी डिटेल में आ जाएगी. Uses sulfur compounds के sulfur dioxide के uses actually हमारे कोर्स में exist करते हैं. First, manufacturing of paper. उसमें ये pale yellow color को remove करने के लिए होता है, तो sulfur dioxide actually acts as a bleaching agent and it colors the paper white. This is the first use. The second use is that sulfur dioxide is used in food industry to kill bacteria. Now, this one is to use to dry apricots in wine. हम पेपर की ब्लीचिंग में क्लोरीन इसलिए यूज नहीं करते, क्लोरीन बहुत हार्मफुल एनवायरनमेंट के लिए, सल्फर डाइऑक्साइड लेस हार्मफुल है. हम फूड इंडस्ट्री में कॉन्सेंट्रेटेड सल्फ्यूरिक एसिड या इस तरह कोई डिहाइड्रेटिंग एजेंट यूज नहीं कर सकते, या बैक्टीरिया को खत्म करने के लिए कोई ऐसी चीज यूज नहीं कर सकते जो पॉइजनस हो. That's why we stick to sulfur dioxide. Now, moving on the next page, we have the portion that discusses the exact industry. Okay? We take air and sulfur and we burn sulfur in it to convert it into sulfur dioxide. We mix the gases and clean them up with electrostatic precipitation, sulfur dioxide and oxygen that is, and we convert them into sulfur trioxide. In chapter 7 में पहले discuss कर चुके हैं. The reaction conditions are 450 degrees centigrade and 1 to 2 atmosphere pressure. आपकी बुक में पहले 1 to 5 atmosphere pressure भी लिखा हुआ है. Both values are fine. Actually, we need a little bit of pressure only. Vanadium 5 oxide or V2O5 as per the formula is the catalyst that is used, and the yield eventually is 98% sulfur trioxide. What we do is that we keep on recycling the unreacted gases. Sulfur trioxide is then mixed in H2SO4. This actually is modern method. अगर यहाँ से आप इसे डिवाइड करना चाहें तो आपके पास ये मॉडर्न मेथड है, और इसका ओल्ड मेथड में सेपरेटली डिस्कस कर देता हूँ. ठीक है, मॉडर्न मेथड इज दैट वी add sulfur trioxide in 98% sulfuric acid. You'll ask, or a question might come to your mind, that how can we bring this 98% sulfuric acid? We either purchase it from the market in the first go of the plant. As soon as the plant starts producing its own sulfuric acid, we can reuse it over here. This converts it into oleum, the formula of which is H2S2O7. Oleum is then diluted with water whenever needed, the reaction of which is not written over here, which is actually H2S2O7 plus H2O, and that can give you H2SO4, double the amount of oleum. This is, however, ये जो है ये old method की equation है. We can also go with sulfuric acid plus water to form sulfur trioxide with water to form sulfuric acid. This is old method. This is not used anymore. It has many problems. For example, it produces acidic mist or acidic fog, whatever you'd like to call it, which is pretty harmful. This is an extremely exothermic reaction. So exothermic that it is difficult to control. And containers are attacked. At this high temperature and this exothermic reaction with acidic mist and fog present, any kind of containers are attacked by it. So this is not used anymore. This is actually an obsolete method. This one. This is the equation for the old method. This is the equation for the new method. New method is far better. If you go for a comparison, new method is better because oleum is easy to handle and transport. Let me tell you, oleum is almost least acidic as example as I can come up with. So oleum is very easy to handle and very easy to transport. Now, oleum's transported diluted at site and finally, last but not least, gives double the amount of sulfuric acid. As you can see in the reaction on top. बहुत आसान है. Sulfuric acid बहुत strong acid है. उसको transport करना, उसको handle करना, हमें special equipment चाहिए होगा. Special cars, lorries या इस तरह की चीजें चाहिए होंगी. ठीक? जिनके containers ऐसे हों जो इस acid के साथ आसानी से react ना करें, handle कर जाएं इसकी transportation. Oleum on the other hand is literally very easy to handle and transport because oleum is very less acidic. When oleum is transported, let's say an industry has ordered 10 tons of sulfuric acid, then only 5 tons of oleum would be transported. It would be diluted at site, wherever it is transported to, with pure water, and it would give double the amount of sulfuric acid. So only 5 tons of oleum would be good enough to give you 10 tons of oleum, sulfuric acid. So then this new method has all the benefits in comparison with the old one. Plus, oleum does not have any acidic mix or fog in its preparation process, and the reaction is not extremely exothermic as well, as compared to the old one. The comparison is not given in this book, however, it is present in reference books. The comparison has been discussed in exams previously as old and new methods. The comparison has been discussed as a new discussion scenario in different papers, mostly as a new discussion scenario. They would ask you a question that we can mix sulfur trioxide with water and it would also produce sulfuric acid, then why don't we go with it? And you should know why we don't choose it as as a part of this process.
ठीक sir.
Okay, let's move on. So I was talking about the uses of sulfuric acid. So plastics or cleaning metals, we have discussed these, paints and pigments, fertilizers, we have discussed this. When they ask about paper, about the specific fertilizer that is made from sulfuric acid, don't forget the specific fertilizer we made from sulfuric acid was ammonium sulfate. And it was when ammonia reacted with sulfuric acid to form this one. So this is the fertilizer we used to form from sulfuric acid. Then there are fibers and dyes and tanning of leather and soaps and detergents. Concentrated sulfuric acid is a very powerful dehydrating agent. An experiment is coming up next page, which would tell you how it can capture water from almost anything around it. Then it's a powerful oxidizing agent. It has oxygen atoms to give, of course, and it is very corrosive. Dehydration means removal of water or the elements of water in the same concentration from or capacity from a substance. So We're going to perform an experiment. This is commonly known as a cold tower experiment. We take some sucrose. We can also take glucose. We can take any carbohydrate, because remember, any carbohydrate would have the same formula, that C would be X and it would be YH2O. Means H and O are always in the ratio of 2:1, just like they are in water with carbon. That's why we have the name carbohydrates. Take a look at this one. This number might be different, but these numbers are always in the ratio of 2:1. So what happens that this entire water of 2:1 is taken out, and we are left with only carbon while using concentrated sulfuric acid. Remember, concentrated sulfuric acid, not the dilute one. And thus, this is capable of taking out all the water, and we are just left with soft coal. This is also known as a cold tower experiment. I think you would also do that in lab. So hopefully you would be able to say it. This acid we dehydrate other carbohydrate materials such as paper, clothing, wood in a much similar way. That's about it for the sulfuric acid.
ठीक sir.
Okay, moving on, the chloralkali industry. Remember, the word chlor comes from chlorine and the alkali comes from NaOH. So these are the two major products of this industry. We have discussed this industry back in chapter number 4. So this is the electrolysis of concentrated sodium chloride solution. We used to call it brine as per the name of the scientist. We have multiple electrode cells like mercury cathode cell or diaphragm cell for this purpose, but these are the old ones and not much discussed. They haven't been discussed in past papers, so I'm going to skip it simply. Just one piece of information that I'd like to tell you is that diaphragm actually acts as a separator, more like a membrane. However, we have modern membranes, we call them membrane cells, and they are actually selective ion exchange membranes. Selective means they are going to be partially permeable. As per your biology subject tells you, partially permeable membranes are the membranes which are capable of passing a few specific type of ions, and anything larger in size is simply blocked. In this specific case, I hope you remember that the sodium ions were able to pass, the water molecules were able to pass, but the fluoride ions were not able to pass. So these exchange worked very well with it. Now, in this process, there are 3 products. Chlorine is produced at anode, hydrogen is produced at cathode, and the system is left in the form of sodium hydroxide. Now, one point they are trying to tell you right below it is that one factory in UK consumes 1% of entire UK electricity output. Let me tell you, UK is one of the countries in the world which are producing most electricity output. So this is a lot of electricity. But they're trying to tell you, the point they're trying to make is that any procedure that includes electrolysis is going to be extremely expensive in terms of the price of its products, just because it consumes a lot of electricity. Now let's talk about the uses. Chlorine, poisonous yellow-green gas, used to make PVC. We're going to talk about in chapter number 11. Solvents for dry cleaning, chapter number 10. Paints and dyestuffs, bleaches, we have discussed bleaching before. We are going to discuss it again in chapter 12. Weed killers or pesticides because it's poisonous. Hydrogen chloride or hydrochloric acid. Remember, this is HCl and this is a gas, and this one is HCl when dissolved in water, so this is aqueous solution. So there is a difference between hydrogen chloride and hydrochloric acid. This is also used for killing bacteria in water supply or swimming pools. Sodium hydroxide is alkaline and corrosive. It's used to make soaps. Soaps are not a part of your course anymore. Detergents, textile, and paper. So you're just supposed to remember the uses. For hydrogen, which is a colorless flammable gas, it is used to make margarine. We're going to discuss it in chapter number 10, or nylon in chapter number 11. Again, we have hydrogen chloride and hydrochloric acid, same as I explained before. Now, this topic doesn't just end with the uses of all 3 products that we have from electrolysis of brine. Instead, this topic continues with the uses of all 4 important halogens, keeping acetate out. We know about fluorine. It's used as fluoride form in toothpaste and drinking water, or in PTFE, which is non-stick coating for frying pans. I hope you remember it by its common name, which was Teflon, or PTFE stands for polytetrafluoroethene. Fluorine for water treatment, bleach, we have discussed it many times. Let's simply skim through it. PVC or solvents for dry cleaning, disinfectants, antiseptics, and pesticides. Bromine, flame retardant, and pesticides, petrol additives, and photographic film. I hope you remember that we had good quality images if we used AGBR instead of AGCL. So we use it in photographic films. Iodine is an antiseptic. I hope you remember the commonly used Iodex and photographic film. If we use AGI, the quality is not just good. In fact, we can use it for high-speed photography. This links to the photography topic from chapter number 7. All right. So we're able to use AGBR and AGI instead of just AGCL for a better photography. But this is all a news of the past. Digital photography has replaced this kind of photography a long time ago. So this concludes the chlor-alkali industry as well. Let's talk about limestone then. Limestone is a very important material, a raw material, and a directly used substance. Limestone is present in the form of chalk or marble or shells that are usually a part of eggshells or seashells. It is present in different forms. It is used for many different purposes. Remember, a big part of limestone is present in chapter number 5 and chapter number 1. However, some industrial related part is also given over here. Direct uses of limestone for neutralization of acidic effects by acid rain. It is used to obtain calcium oxide. It is used in the extraction of iron or to remove the impurities from the iron ore. These are 3 uses that we can memorize, and their uses has been a part of past papers, but we consider it an easy question. Another use, it is used to make cement. Cement is actually heating powdered limestone with clay, and we also add a small amount of gypsum, which is CaSO4.2H2O. Gypsum is actually there to increase the settling time. I hope you understand that cement has a specific settling time. In that time, you can reshape it or remold it. If you go more than this given settling time, the cement will harden. And the same thing is written over here. When water is added to cement mixture, complex chemical reaction takes place, and they give a hard interlock mass of crystals. Now, we don't go with the entire chemical processes. However, the crystals that are formed are a part of your book, as well as been a part of past papers, but rarely. Calcium aluminate, the formula of which is CaAlO2 twice, and calcium silicate, CaSiO3. Remember, this was slag from the blast furnace. Concrete, however, is a mixture of cement and aggregate, which includes stone chipping or simply speaking gravel. And we mix it with water and we pour it into wooden molds. We then allow them to harden and we then use them for building purposes. Concrete is now a much preferred material for building purposes than any other form of mortar that was available in the past. Reinforced concrete is also a good idea for a multi-story building. That is, we use concrete around steel rods or mesh, the diagram for which is given over here. There are steel rods in mesh, and we are going to fill them in with reinforced concrete. All right, and that will give the structure a lot of capacity to bear weight. Then we have sodium carbonate among one of the carbonates, which is important. It is used in the manufacturing of glass, soaps, detergents, or papers. Right? This is simple, straightforward facts. You can simply memorize them. Manufacturing of lime.
Sir.
This one is important in terms of what we studied back in chapter number 7, about the dynamic equilibrium and the Le Chatelier's principle. That principle said that if we bring any changes to the conditions of concentration, pressure, temperature, or catalyst, we can change the effects or the position of the equilibrium, but the system would try to oppose that change as much as possible. In this specific case, if we go perform this entire experiment, the thermal decomposition of calcium carbonate, giving us calcium oxide and carbon dioxide in a closed container, nothing would happen. But if we do it in an open container and we let this gas go out of the system, the reaction will always keep going on forward, and all the calcium carbonate can simply be thermally decomposed into calcium oxide. Remember, this one is limestone and this one is lime. This one is also known as quicklime. The name might not be written over here, but it's definitely written in chapter number 1. This one is then mixed with water in this reaction and is converted into slate lime, also part of chapter 1. Slate lime, which is also written over here. We also make bleaching powder out of it. We also use it in formation of glass. The diagrams for cement are given over here. Powdered clay with limestone in a rotary kiln and converted into cement, which is then added to sand and gravel and water to convert it into concrete. And if concrete is poured along with the mesh, rod mesh, iron rods or steel rods, this is known as reinforced concrete, all used for building structures. The glass is simple and straightforward in our book: crushed limestone, sand, and soda. We heat them up and we later on mold them into different shapes to get the glass. The limestone reaction I was talking about, if the limestone goes in, hot air comes from the other side, interacts with the limestone, decomposes it thermally, and takes the carbon dioxide. We can keep getting on the quicklime out of the limestone we send in. The reaction can keep moving in the forward direction as per the Le Chatelier principle says, and as far as we're going to have the reactants, we'll keep getting the products. This finishes the lime industry as well. Let's move on to the end of this chapter. Let's finish it up. This chapter discusses about chemical plants. Where do we put up a specific chemical plant? I'm just going through these facts. They have been discussed really just once or twice in past papers. So just remember them if you can, but don't waste too much time on this page. Just this part is important enough. The availability of raw materials needed by a process in the chemical plant. The transport links for importing the raw materials or exporting of products will also decide where should we put a chemical plant. The availability of a workforce and labor, the people who are going to work over there, the nearness of customers who are going to use our product, and environmental considerations are all the factors that we take into consideration before we put up a specific chemical plant at a specific place. Talking about that, when we talk about putting chemical plants, they always come with some side effects such as environmental costs, so we need to go with those environmental costs. The environmental costs can be air pollution, water pollution, land pollution, or appearance of the surrounding. One by one, starting with air pollution, acidic or poisonous gases are often a part of chemical processes. They can lead to acid rain, so it's better that if we remove those gases by scrubbing, which is simply water shower, or we may react them with an alkaline substance such as limestone or lime before they leave the industry. Is a very good way to reduce air pollution. When we talk about water pollutions, liquid waste or cooling water that comes out of the industries or factories, we must treat it first. We must understand and know the laws that govern the system of water waste or its management, and we must stick to it. Poisonous materials should be removed by adding sodium hydroxide, which usually filtrates, which usually precipitates the poisonous materials out. We can filter them up before we let the wastewater go out of the industry. If we talk about land pollution, soil heaps are often produced by industries. Poison substances are often produced by industries. It's not safe to live because of the poisons in the ground. So we have been dumping them in the ground, but it's better to treat them before you dispose them off, whether in the ground or out in the open. Appearance of surroundings, when you're done with a place, when you're done with an industry, let's say you have spent 40 or 50 years, 3 or 4 decades at a specific place and you're done with it, then if you're going to leave the place, make sure it looks like a little bit better place in terms of aesthetics, just like this one. Right? Recycling,
ठीक सर
3 simple and straightforward points. Just memorize them and you would be good with most of the questions of recycling. It conserves the raw materials because we recycle and reuse the thing that we have used before. Number 2, it often uses less energy. As we have discussed before, if we are talking about 100% energy on the electrolysis of bauxite to get aluminum, only 5% would be used to recycle it. So that's a lot of considerable savings in energy costs, right? And last but not the least, the third point, avoid need to bury the landfill sites, which are really becoming a headache around the world as they are increasing more and more. So aluminum saves a lot of energy in recycling. It can be recycled. Iron and anything made out of iron and steel can be easily recycled. Before we can recycle it, magnetic separation is the easiest way we can separate them from the rest of the waste heaps. Glass can easily be recycled because glass can be heated and remolded for a better or new shape. Plastics, however, are a problem. They take around 700 years to decompose. The simplest kind, the difficult ones take even more time, but we can recycle plastic too. Paper can easily be recycled 4 to 5 times before it cannot be recycled again, but that saves a lot in energy costs and as well as in terms of trees. That's about it for chapter number 9. Any questions?
no sir
नहीं सर
All right. So let's just wind up today's class a little early. All right.
जी सर
Allah Hafiz.
अल्लाह हाफिज़ सर मेरे वो पेपर